Hello everyone, this is Harsh, and in today's video we'll be discussing kinematics of rolling wheel. To be precise, we'll be discussing cycloidal trajectory and okay, so we'll be discussing cycloidal trajectory and distance traveled by a point P in a rolling wheel. Okay, wait. So we have a body over here which is rolling. It's having an angular velocity of omega at time t, radius r, and it's moving forward with velocity cm. As we discussed in the previous video, it's a body with a combined motion, right? So we're taking a point P over here, point P, and we have to find out how much distance it will cover while it's rotating. Okay, so we're assuming this to be point P. We are taking this as the axis. This is the x-axis and this is the y-axis. So as this body moves, we know that it's moving VCM, and then VCM is also VCM is also r omega. They will also move with r omega. Alright, so it is having VCM r omega, theta is equals to omega t. At time t, the point P will reach somewhere over here. So let us assume this point P over here to be x, y. Now, if this point over here, excuse me, yeah, so if this point P over here is x, y, and then this distance over here will be the y coordinate, right? Will be the y coordinate, which means if this is r, this one over here will be r sine omega naught, and then we'll have, so let us represent this as x and y. X and y. X will be, now we will assume the distance over here from this point over here to over here to be obviously it will be VCMT, right? Because velocity into time equals to distance. So VCM. So to find x, which is here, x, this will be the distance x, we'll have VCM into t minus r sine omega t, because this distance over here is r sine omega t, right? Because this is r, and then distance, this y coordinate over here will be r cos omega t. The y coordinate, this one over here, this y coordinate will be r, this one, r cos omega t, and this distance is r sin omega t. Okay, so x is equals to VCMT minus r sin omega t, and then we are having y is equals to r minus cos theta, r minus r cos theta, which is definitely r minus r cos omega t, since theta equals to omega t. Okay, now if you want to represent this x and y, we can represent this in a different manner, which could be x minus VCM into t whole square plus y minus r square is equals to r. This is by using the Pythagoras theorem. We're just substituting this, right? We're just taking this point over here, this point over here, and we are representing this one. So x minus VCMT, y minus r whole square equals to r over here. Okay. Now, If we are asked to find, for example, say we are asked to find distance traveled by p, right? So what we could do is, let us just take a circle over here. We could represent this like this. We can represent this like this. This one over here will be Vy. This one over here will be Vx. And we also have an R. Yup. Cool. So Vx. Okay, wait. So what will Vx be? Vx is basically the differentiation of point x, right? And point x, the distance of point x is given over here. So all we have to do is differentiate this, and it would give us the value of velocity of x, which will be dx by dt, dx d into dt vcmt minus r sine omega t, which will give us vcm minus r omega cos omega t is equals to velocity of point x. This is what we have. Alright. And now similarly we'll also derive Vy, which is velocity of point y, to be dy by dt, differentiating this, and then we get r omega sine omega t. When you differentiate, r minus r cos omega t. This is what you get. Cool. And now we have, let me just write it down clearly once again. Vx is equals to Vcm minus r omega cos omega t. Vy equals V naught sine omega t. This is equation 1. This is equation 2. Now let me just so I hope you got the idea. Vx over here is this one, Vx over here is this, and Vy over here will be r omega sine omega t. This is how we are going to represent it. We are going to represent it as in the following way. Cool. Okay, so we have Vcm minus r omega cos theta, and then Vy equals to r omega sine omega t. Since this one will be r omega, this is r omega, then this is Vcm equals to r omega cos theta, and then Vy is r omega sine theta. We just write that down clearly, r omega sine omega t. Cool. Great. Alright, so now at time t we know it's the p is at the bottom. Now at time t, if we have to find the distance traveled for a whole circle, we know that t is equals to 2 pi by omega, the time when it will complete a whole revolution, right? So we're taking t equals to 2 pi by omega, and then we know that distance is equals to integral of magnitude of v into dt, which, and omega magnitude of v is equals to vx square plus vy square dt. And now we'll have distance s equals to integral from 0 to pi omega. All we have to do now is just substitute Vx, Vy from the above values, and we have to find integral Vcm minus r omega cos omega t, r omega sine omega t as Vy, and then we get this huge answer, which would be V naught plus V naught square cos square omega t minus 2v square cos omega t plus v square sin square omega t. This is root, and then we get a dt, which is, we'll just write this down once again neatly. V naught square cos square omega t minus 2v naught square cos t plus v square sin square omega t into dt. Great. So this is what we get, distance. Now we just want to simplify this, right? We're just going to take v square common in this and this. We get 1 v square, 2 v square. So we'll get 2v naught square as common. S is equals to 2v naught square into 1 minus cos omega t into dt. Then this is equals to distance. Now we'll have okay, great. So we also know that cos 2 theta equals to 1 minus 2 sin. Just keep this for later, okay? So, and we'll have VCM. Then this one will be 2v naught sin theta by 2. So we'll be taking that as equals 2v naught square into 2 sin square omega t by 2 into dt, which will give us s equals to 2 pi omega by 0. We took out the squares, sin omega t by 2 into dt, and upon simplifying this we have 4v naught out pi omega 0 sin omega t by 2 into dt. Now let's just do this separately. We have minus cos omega 2 omega t by 2 0 to pi by omega into 2 divided by omega, which will give us minus 2 omega cos omega into pi by omega 2 into, that will be minus 0, so we'll have 1 over here, which means upon simplifying this we get 2 by omega, and therefore we can substitute this back into the top. We can substitute this one in here. Great. Okay, so we'll have 4v naught into 2 into r by v naught equals to 8r. Therefore, distance traveled by point P is equals to theta, and